Another pass at identifying transformations. And in this example here, we're actually going to use the formula for converting temperature in Fahrenheit degrees into Celsius degrees. But we're going to use it as a function and actually graph it. And so that is the function C of x Celsius is equal to 5/9, 5/9, times x, and x is the temperature in Fahrenheit, minus 32. And we can use that to determine the temperature in degrees Celsius when given the temperature in degrees Fahrenheit. So we're asked to describe the transformations in the function and then graph it. Well, there's two transformations that I see. The first one is right here. This 5/9. This is going to create a dilation. And because 5/9 is, it's greater than 0, that's for sure, but it is less than 1, it is going to compress the function. I can also see that this is going to be a linear function, as it's just x. And we're going to have a horizontal translation or a horizontal shift to the right. And so let's see, you got that negative. Because when I distribute this 5/9 times x minus 32, I'm going to end up with 5/9 x, 5/9x, minus, let's see, 5 times 32, 5 times 30 is 50, and then 5 times 2 is 10, so that's 160 divided by 9. 160 divided by 9. 9 will go into 16. 160 one time, with about 7 left over. So it's going to shift it about 20 points to the right. I guess, somewhere like that. All right, well, let's jump over to the calculator and let's just graph this function just to complete this particular exercise. All right, well, here we are. We're going to briefly graph this function. Let's clear out what I had in here. And so let's see, we got 5/9. Y is equal 5/9 times x minus 32. I probably should have done some window adjustments. Well, let's go ahead and, let me go ahead and hit here. Let's see. So the x-axis is degrees in Fahrenheit. Let's change this to -50. I didn't want to do that. -50 for x min. Let's move x maximum maybe to 50. And let's give it a scale of 10. And I'm going to leave the y minimum, y maximum, that's the degrees in Celsius. I'm going to leave it alone. Let's graph this thing. All right, well, there we go. I see that it has had a horizontal translation, a horizontal shift to the right, and that makes sense actually right there. When x is 0, when y is 0, x is going to be about 32. That makes sense. Let me go in and just graph just a regular linear function. We'll see how that dilation is a compression. It's kind of pushing it down towards the x-axis. It's going to be in red. You can see it kind of flattened it a little bit. It doesn't have as steep a slope. This is going to have a slope of 1. The blue line's got a slope of less than 1. So we've had a dilation. It's compressing it. and we've had a horizontal translation. Those are the two transformations in our graph. Shazam.